with the still game. So for Leetcode problem 1563, still game 5. So there are several stills arranged in a row, and each still has an associated value with which is an integer given in the array still value. So let's try to use an example. So we're gonna use this kind of example. So we have an array, and inside of the array there are gonna be some values. So maybe 62 3. So 6 2 3 4 5 5. Yeah. So for each of the turn, we can split the array into two parts, and we will remove the sum of the, and then we're gonna sum up of all the values, and we're gonna choose the smallest part. We're gonna remove the biggest part. Maybe so for example, this is 11 and this is 13. So we're gonna remove this 13, the right part, and what left behind is just the left part. And Alice and Bob playing with this game alternatively. So the first turn gonna be Alice, and then it's gonna be the Bob. So we're gonna return the maximum score that Alice can obtain. So if we remove from the right side, so this is 6 plus 2 plus 3, so this kind of a score, so it is 11, so that is the score of Alice. So this is just finishes Alice, and now Bob want to decide from 6 to 3, and Bob want to choose something. Maybe Bob want to choose remove this 6, and Bob will get a score of 5. And then Alice has only 2 and 3, so Alice will remove 3 and get a score of 2. So in this way, Alice got a score of 13, but Bob got a score of 5. Is this as we expected? Because we want to return the maximum score. So maybe this kind of splitting is not the optimum. So we want to find the optimum splitting. So as you can see the example, it is the optimum. Alice will divide it into two parts, so this is okay. And Alice will get a score of 11. And in the second round, Alice will divide it into those two parts. So in this turn, Alice's score gonna become 16. Because maybe I forget to plus something. So this is 11 plus this 5, so it is 16. Now what left behind is the last round. Alice can only have one choice. So Alice can only remove 3 and get a 2. So Alice's score is 18. So in this game, actually Bob didn't do anything, because Bob didn't do the job as Alice. As you can see, Alice divided into two parts, and Bob just calculated the value of each row, and which is the sum of the values of all stills in a row. Bob throws away. Actually you can understand the whole process as Alice. But it is said Bob, so Bob just didn't do anything, just split the array into two parts and sum of them, and Bob threw away the maximum value, and Alice's score just increased. So if the value of the two rows are equal, Bob lets Alice decide which row will be thrown away. So if the two parts are equal, so Alice can decide which part to throw away. So in this way, because Alice will play optimally, so Alice gonna choose both ways. Let me redraw it. So we have an array. If this decision is by Bob, definitely we're gonna choose the smallest. So this is the left side, this is the right side. Definitely we're gonna choose the smallest and remove the biggest. So because this decision is made by Bob. But what if the array is equal? I mean the sum of them from the left side and the right side is equal. Now Bob will not decide to remove anything. It will be decided by Alice. So Alice can choose the optimum way. So Alice can choose two ways, from the left side or from the right side, but definitely Alice will get the maximum. So we're gonna define this function as a DFS plus memorization. So the DFS part is just from the L to R. So this is index 0 to n minus 1. So this is our DFS. So this definition is the maximum score Alice can get if she play optimally like this. Yeah, and for this function, if this L equal to R, it means we have only one still left behind, so we're gonna return a 0. So this is according to the question. If there's only one still remaining, Alice is initially 0. Yeah. You can say the game ends when there is only one still remaining. So this gonna be the end if there's only one still remaining. For example, this 5, and Alice initially 0. So Alice's score is initially 0. Yeah, and we're gonna return the maximum score Alice can get. And for each of the inside the DFS, for each of the for loop, we're gonna split the array into 2 parts, and we're gonna check all those combinations. So this is like a brute force inside the DFS, and we're gonna choose the maximum. And inside the for loop, there's gonna be some check. We're gonna check if the left side is bigger or the right side is bigger, or they are equal. We're gonna have the different decisions. Yeah, and the decisions is easy to check. Yeah, we just need to decide we're gonna choose the left side or right side. Yeah, so this is the decision. Or we're gonna choose both sides and check the maximum if they are equal. Now let's go back to the coding part. So I'm gonna, as always, define a class, and I'm gonna use the DFS. So inside of the DFS, it is L to R. So the decision for the boundary check is if L equal to R. So I'm gonna return a 0. So this means there's only one still remaining. I cannot get anything for Alice. So it's gonna be 0. Now let me just call the DFS first. So for the DFS, it's gonna be from 0 to length of still value minus 1. Now let's get started for the DFS. So for the DFS part, we're gonna define some variables just for checking of the left sum or right sum from the right side. Yeah. So the total gonna be 0. So the sum of the left part and the result gonna be my final DFS result. So it's gonna be 0 and 0. Then I'm gonna loop through all combinations. So from L to R, I'm gonna loop through it, and the sum of the left part gonna plus equal to the still value. From the left side, it's gonna be I, and sum of the right side, yeah, it's gonna equal to the total. So it's gonna be total minus the sum of the left side. Yeah. So here I need to calculate this total. So this total is gonna be the sum of the values of the still value from the left side to the right side. Yeah. So it is L to R plus 1. So it is left side to right side, because this L and R is included, as you can see from the definition. Now we finished the left side and the right side. We can continue to check it. So if the left side is smaller, now we're gonna go to the left side. So we're gonna have the result, and gonna be the maximum of the result with DFS from the left side. So it's gonna be L to I. It's gonna be the left side, and then we're gonna plus the sum of the value from the left side. And if we're gonna check if this is sum L is bigger than sum right side. Yeah, so we're gonna choose from the right side. So it's gonna be the maximum of the result with DFS from the right side. So if we check from the right side, definitely it's gonna be I plus 1 to the right side, and we're gonna plus similarly for the right side. And we need to be careful with the definition here, because this I is defined inside L from L to R minus 1 actually. So this is from I, the maximum of I is I minus 1. So this I plus 1 just means this value R. So in this way, actually we checked all the combinations. So you should be careful about this kind of definition, or you can use other definitions, but you should have the boundary check. You have to include all kind of combinations. And what we left behind is only one though. We need to keep this kind of a definition. And else is that if that equal. if they are equal, we're gonna choose the maximum of the two. So inside it's gonna still be max. But here we're gonna prepare another max. It's gonna be maximum of L to I and DFS with R plus 1, I plus 1 to R. And the maximum of them gonna plus the sum L or sum R. It's gonna be okay for both of them. But you need to choose either of them, sum L or sum R. Yeah. So this is gonna be the final definition. We just need to return this final result. Yeah. So if everything's okay, normally for the testing case it should pass. But let's just have a check. Now as you can see, it passed the testing cases, but I'm not sure if it can pass all testing cases, because as you can see the time complexity, it's gonna be n cubic, because this is 500, this is L and R, it's gonna be n square, and there's another for loop, it's gonna be n cubic. As you can see, it cannot pass because it is the time limit exceeded. Actually, it passed all testing cases, but there's gonna still be a time limit exceeded because Leetcode has another testing system. It will not only test the all testing cases, but it will also calculate the time. Maybe the time is too long, maybe it is 10 seconds or 12 seconds, but definitely it is too long. So this means we're gonna optimize the code. So in order to optimize the code, we need to understand, at which part we might possible to optimize it. So from here, this one, we cannot optimize it. Maybe inside the for loop, we can optimize it. So the idea is that definitely at each of the iterations for this for loop, we're gonna split the array into two parts, the left part and the right part. So while we are splitting, the right part is gonna be smaller and smaller. Yeah. So maybe this is 8 and 8 after another splitting. Because of the for loop, the I will be continued to the next. So this may be 10 and this may be 6, but the sum of them are going to be equal. Yeah, it's going to be smaller and smaller. So we can only check the right side. So what if the right side, this is 6, but our result has already become, our result is 6. Yeah. So this means, so our result is 6, but what if the right side is 3? Yeah. So this means if this right side is 3 and this is 13, so for the right side, if it is 3, so what is our definition of the DFS? So we're gonna plus a 3 first, and then we're gonna have a DFS from this right side. And what is the DFS for the right side? Definitely it's gonna be smaller and equal than 3. So this means if the sum of the right side is equal to 3, definitely we don't need to check, because 2 times 3 is less than or equal to 6. Yeah, because the left side, definitely it's gonna be bigger. It doesn't matter because the right side is become smaller and smaller. So definitely we can check it like that, because for each of the term, definitely we're gonna choose the minimum. Yeah. But what if from the left side it has already become a smaller value, maybe 2? It doesn't matter, because we're gonna only consider the right side, because at the right side it has already become 3. Even it is not the minimum, it is okay, but if we choose the minimum, maybe 2. If 3 meets the condition, 3 times 2, 2 definitely meets the condition. So it doesn't matter about the left side, we just need to choose from the right side. If the right side times 2 is less than or equal to the result, definitely we don't need to check that, we're gonna break the for loop. Yeah. Now let's optimize in this way. So if sum of the right side times 2 less than or equal to the result, definitely we don't need to check it. We can break the for loop immediately. So in this way, maybe we can reduce the algorithm from 500 times 500. Yeah, let's just calculate. So we can reduce it from, because 500 cubic, so the value is gonna be 1.25 times 10 to the power of 8. Definitely for Leetcode we cannot pass while we are using a case, because this is a hash table. It's going to be really slow in Leetcode or in other system, because Python, while we are using the case, it's going to be really slow. So we want to optimize it from here. So normally for this kind of trimming, we can reduce it by 2, definitely. So it's going to be 5 times 10 to the power of 7. So that is why we can pass for this problem. Yeah. Now let me just try to check, submit it, and check if we can pass. Yeah, as you can see, we passed, and it is 3 seconds. So normally it should be okay. Maybe before it is 10 seconds. Now it becomes 3 seconds. Thank you for watching. See you next time.